Hello, Conceptual Physics. It's Mr. Fumato checking in with a video update. And I just wanted to give a quick thank you to those of you that wrote to me to tell me that the Pivot Interactives were confusing or complicated or you didn't quite know what to do. It's very important that I hear from you if you have a question about something that I've assigned. As I know you know, I am new to distance teaching, and as you are new to distance learning. So the more information I get back from you, the better off we will both be. I have a couple of quick announcements, and then I have a quick how-to video. So some announcements that I want you to be aware of. Number one, the Collisions Pivot Interactive, the one that is on my screen here, will be not graded. It will be formative, and you should consider it to be practice. Practice for what? Well, I am going to give you an assessment on Tuesday of this week in the form of a different and hopefully simpler Pivot Interactive, uh, which will be due at 5 o'clock. So the Collisions Pivot Interactive will not count, and then I will upload a different and hopefully simpler one for Tuesday. Another quick note about the wrapping up the momentum unit with the quiz on Tuesday is that the quiz will be collaborative. So I'm going to set up Google Meets for you to communicate with your lab partner. So these will be the people that you've been working with all semester, that one other person, and I will ask you to work through the pivot together and then submit your own work. Okay, so that is the three announcements. So there will be no grade associated with this collisions work that you've been doing. We will, however, have a quiz on a similar pivot on Tuesday, and then finally that quiz will be collaborative. Those are the announcements for now. Now let me just go through a quick how-to here with the measurement of velocity and then the calculation of momentum in a Pivot Interactive. So the whole point here is to take advantage of the very slow-mo, high-quality videos that we're analyzing. So one thing that you might not remember from back in the day is that the pivots are set up so that you can use the left arrow and the right arrow on your keyboard to advance the video frame by frame. So right now I'm pressing the right arrow, which is advancing this thing forward in time. And to prove that to you, if I open up the stopwatch, I'll get the rulers while I'm here, you can see that the frame number, if I click back into the video, will go up if I use the right arrow. So to determine the conservation of momentum in this interactive, we want to verify that the total momentum in the entire system before they collide is equal to the total momentum after they collide. So to find the total momentum, we would add up the momentum for each individual cart and be very careful to recognize that left momentum is negative. To find each individual cart's momentum before and after the collision, we need to know the cart's mass and the cart's velocity. So the masses are labeled here, 150 grams each. The velocities you need to measure. So the way that we do that is we find a few frames before they collide. We line up our rulers so that, let's say, the 10 centimeter mark here is just at the very left. And I'm going to reset my clock. I'm going to go forward by some number of frames. Let's see, they haven't collided yet. They're just about to collide. Let's see, I backed up 2 frames. This card on the left here moved from 10 to 9 to 8 to 7. So that's a total movement of 3 centimeters in a time of 0.0833 seconds. So at this point in your physics career, you know how to compute velocity given a distance covered and a time elapsed. Go ahead and do that. And then back up a few frames and do the same thing with the card on the right. I'll put let's see, the 20 mark here at the very edge of this cart. Then I'll click back into the video frame, and then I'll go forward some number of frames. Oh, forgot to reset my clock. I'm going to back up. So let's see, reset. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 frames. So how do I know where to stop? Well, I'm just stopping when the cart is at a very easily measurable part of the ruler. So it went from 20 to 17, so that's 3 centimeters in 0.083. oh, look, that's the same velocity, it's just negative. So what's the total momentum in this two-cart system? It's zero. How do I know that? Well, if I did the math out, 150 times the velocity here plus 150 times the exact same but negative velocity here, the whole momentum sums up to zero. Okay, that would go in these tables. We would do the same thing for after the collision, and then we would compute the momentum. So that's his sort of quick tricks for determining velocities and then calculating momentums. And I am very much hoping to hear from you with questions. And then look soon for announcements about optional tutorial times with me and or Mr. Norris. Thanks very much.